Alright, welcome to this video on anti-differentiation. So, what is anti-differentiation? Well, we've learnt to differentiate functions. Anti-differentiation is just the opposite of finding the derivative, or the opposite of differentiation. So, let's look at a moment. So I imagine that I have y is equal to, oh, say I have dy dx is equal to x squared. What I want to do, or what we can do with anti-differentiation, is find what was this function before we differentiated it. Well, we know that from our rules of differentiation that we take the number up here, or the power that it is, we put it out the front, and we reduce it by 1. So how does this become x to the power of 3? Well, there's other bits missing from it as well. We know that if we were to differentiate x to the power of 3, then that's going to be 3x squared. But the problem is, there's no 3 here. So we have to get rid of that. And the easiest way to do that is to make a third out the front, because 3 times a third is 1. So our actual function, that when we differentiate it equals x squared, is a third x cubed. Let's look at another example. Let's look if we've got dy dx is equal to x to the power of 5. Now, we know that it would be x to the power of 6 to start off with, but when we're going to take that out the front, we'll take our 6 out the front. There is no 6 here, so that's going to have to disappear. The easiest way to do it, again, is by making it making it 1 over 6. So y is equal to 1 over 6 x to the power of 6. So we're just going backwards. We're going from this to this normally. That's what we have been doing. Now we're going from having a derivative and working backwards. So if we go take the 6 out the front, it becomes 6 over 6, x to the power of 5. 6 over 6 is just 1, so x to the power of 5. That's where it comes from. But there's an issue here. What if the graph of this function, or any of these functions, doesn't go through the origin? That is, it's got a y-intercept other than 0. Well, all we can do is add on a plus c to each of these. Because when c is just a constant, if we differentiate a constant, it becomes 0. So it disappears up here. We don't have enough information from this function here to be able to give us all the information for this one. So generally for something like that, we'll be given where the y-intercept is. How does this look in terms of y and dy dx and things like that? You might see it written. So we've got a function f of x. If we derive that, it becomes f dash x. But the antiderivative of this function is a capital F of x. And if we derive this capital F of x, that just equals our f of x. So the only difference is, if we're doing antidifferentiation, we've got a capital F rather than a lowercase f. Alright, let's look at another example. And I'm going to pull one which is 1 over the square root of x. So we know that dy dx is just equal to 1 over the square root of x. This could also be rewritten as the square root of x to the power of minus 1, or x to the power of minus a half. We know this. So how do we take this and step backwards? Well, first of all, if we add 1 onto here, that will give us our what the power was beforehand. So let's write it out. Let's start with it at least anyway. X to the power of 1 on 2. But we still have the issue of what's happening at the front. So what we need to do is come up with something that when we multiply, we've taken a half out the front here, that we end up with nothing, or 1 really. So what is a half multiplied by to get 1? Well, it's just 2. So 2 multiplied by half. So you can kind of see a bit of a pattern forming here. Is that we take the inverse of the power that's left when we add 1 on to it. We take the inverse of the power and stick it out the front. So see here, 6, inverse of 6, 1 on 6, 3, inverse of 1 on 3, inverse of 1 on 2 is 2 on 1, so it becomes 2. So this is our antidifferentiation of this. Though, to tidy it up, we should really go to root x. Now, if you really want to double check to make sure that this really is the answer, find out derive it and see what the derivative of it is. And you should get back to 1 over root x. It is a little bit to think about in going backwards for antidifferentiation, but the biggest thing is making sure that you have a number out the front that is the inverse up here. Hopefully this video has made a little bit of sense and you've got something out of it. If you've got any questions, just ask. We are going to go a bit further with it and look at what would happen if we're using e to the power of something, but we'll do that in class. Any questions, just ask. And as always, thank you for watching. I know it's a bit of a short one this time, which is probably fairly handy for a lot of people. So, yeah, again, thanks for watching, and we'll see you next time.